Hi everyone, myself Praveen. Thanks for watching this video. This video is mostly about VPC. So let's get into the video. So in AWS, VPC is one of the most important service, and this is the starting point of the service in cloud network, guys. So what is VPC? VPC is nothing but virtual private cloud. We can say it as this is the complete isolation of your network in our AWS account, guys. This is a completely private network where no one cannot able to access this to this network without publicly exposing bias. So there are different key components in the VPC. First one is subnet. You can consider like VPC is a large pool of network. It is VPC is a large pool of network. So under that subnet is a segmented piece of network. So which means you can see this is the VPC means these two are all the subnets. So subnets are a segmented piece of network. There are two types of subnet. One is public subnet, another one is private subnet. If the subnet is directly accessible by the internet, that is called public subnet. If the if the subnet is cannot be directly reached by the internet, if the anyone outside the internet try to access to our public subnet, it can be accessible. But for the private subnet, it cannot be directly accessible, which is the private subnet. So we cannot directly access the private subnet via the internet. So the next thing is internet gateway (IGW), which means internet gateway. Now VPC is completely a private network, right? Then how am I saying that the public subnet can be reachable by the internet? So it's done only by IGW. IGW is directly connected to the VPC, which means the internet gateway is the only thing which allows our public subnet to talk to the internet. It will be directly under the control of VPC, which can be directly attached to the VPC. Using the VPC only, IGW, the public subnet is directly can able to speak to the internet and get the data, and you can able to send and receive traffic only using the IGW. The next concept is NAT gateway. NAT is nothing but which is attached to the public subnet so that the private subnet can be able to talk to the internet, which means consider if you are installing a node.js code inside the private subnet. Now the node.js code has to install the dependencies. So for that we need to route the request from private subnet to the NAT gateway, and the NAT gateway will send and receive the traffic through the IGW. So here it plays a major role, which means route table. Route table is used to connect the private subnet to the NAT gateway, and the NAT gateway will be communicating with IGW and to the internet. This is how the flow works. So the NAT gateway will be attached to the public any one of the public subnet, and the request path will be in the route table. It will be connected to the private subnet, so that the private subnet will talk to the NAT gateway, and the NAT gateway will talk to the internet gateway, which means the public subnet will be connected to the IGW, and the IGW will be talking to the internet, so that it can able to install the dependencies in the private subnet. But it can only send the traffic, send the request from private subnet to internet, but the directly to the internet to the private subnet it cannot be directly accessible, guys. So for accessing the private subnet, you will be using the Bastion host. So the next topic is security group and NACL. SG is security group. Security group is like a firewall which is attached before the services. Okay, like NACL. NACL is like it's also a security firewall which is attached to the subnet level. At the subnet level, NACL will be used. At the service level, security group will be used. So in the security group, we will be allowing from this port and this particular IP only the request should come in. Using that, so we can able to secure our resources and services, guys. So this is the theoretical concept of VPC. Let's get into the hands-on. So VPC is nothing but virtual private cloud. It is a completely isolation of your network in our AWS account, guys. So in the security group, we will be allowing from this port and this particular IP only the request should come in. Using that, so we can able to secure our resources and services, guys. So this is the theoretical concept of VPC. Let's get into the hands-on. So this is the VPC place where you can able to access completely VPC sections like subnets, route tables, internet gateways, and a lot more. Here, go to the VPC section and click create VPC. Now there are two methods we can able to create a VPC. You can the first method is you can create a VPC by which is a standalone VPC, which is we need to create a subnet by your own. We need to create a subnet route table and NAT gateway, internet gateway by our own. Just here we will be only the mentioning large pool of network which is an VPC alone. So this is the one method, which means it will take our time to create another resources also. If you are starting the project, you can go with the VPC and more, but you have already created the VPC, and if you're going to create a subnet, then you can go with this your VPC only, this first method. Thus now I am going to use the second method, which is a demo VPC and more. Now I just give a name called demo project. Here you can see the resource map, which will show you the visualization of how it's going to be created. Okay, before that I will be telling you what are all the things that I'm going to create. Here you can see the IPv4 sided block, which is a large pool of network that I mentioned. Here the 10.0.0.6 is a class A, which consists of 65,000 IP addresses. It is a large pool of networks. So you can come under the number of availability zones. Availability zones is mostly used for high availability of our services. So here I am using two availability zones. So our services will be created in the two availability zones. I'm also mentioning the number of public subnet to be true and the private subnet to be true, and I'll be mentioning the NAT gateway in any one of the availability zone. So the NAT gateway will be available in the one availability zone, guys. So this is the thing. Now we can see the resource map. This is how the VPC is going to create right now. So it's going to create a demo VPC, and as mentioned, it is going to create two subnets, which is one public subnet, one private subnet, and the two availability zones, guys. So and it is also going to create a route table. Here for the public route table, it is going to attach the public subnet to the IGW internet gateway, and for the private subnet, it is going to route to the traffic to the NAT gateway, guys, so that only the private subnet can able to reach to the internet. Now you can ask this private subnet can connect to the NAT gateway, but this NAT gateway will be connected to any of the will be created in any of the public subnet, guys. Let's see how it's going to create it. Click create VPC. Now you can see it is going to create a VPC with complete DNS names, DNS resolution, VPC, subnet, NAT gateway, and route table. And it is also going to create a route. Route is nothing but it's where from this address, particularly from 0.0.0, it should route the traffic to the IGW. It's like the same it will be going to create. When you are starting the project, when you're going to create a particular new environment like stage or QA, you can use this particular VPC and more to create a VPC very soon. Here you can see the NAT gateway will take time to time to activate very soon. So until then, you can again come here and refresh. So it will be created. You can see the demo project VPC is created. When you go and set that, you can see the demo VPC is created. Under the VPC, there are four public subnets and the route table, which is everything is created, guys. So if you go to the subnets, you can able to see the different subnets, which is also already created within the own IP like 10.0.128./20, which is a public subnet, which is a segmented network of the VPC, guys. So now you can able to go to the route tables. This is the route table that is created right now. You can see this is the route from 0. This is like all traffic. All traffic can go to the internet gateway, guys. So from the subnet which is associated here can be able to talk to the internet gateway and it can able to reach the internet, guys. So also we are allowing that the subnet can able to speak to the complete VPC resources. So within this VPC, if any services are connected which is created, we can that using this subnet it can able to speak to any of the services which is created under this VPC. So these are the routes that is created. If you want to add routes, you can edit routes and you can also add routes. and you can also associate the subnets, guys. Here, by default, public subnet is attached to the private route table, which is it is going to connect to the IGW. If you want to add any other subnets, you can able to add it here by clicking the subnet association. You can click on, if there are number of subnets that are created, then you can able to attach it here, so that it can able to speak to the internet gateway and to the local network, guys. This is the subnet. Here you can see the internet gateway. The internet gateway is directly attached to the VPC. So you can see the it's attached with the demo VPC ID, and you can see the NAT gateways. Here you can see the NAT gateway. You can see this is connected to public. You can also see this. I also already mentioned that this NAT gateway will be created with under the one public subnet. Here you can see the NAT gateway is created under the inside the public subnet, so that the network request from the private subnet will be reaching to the NAT gateway, and this NAT gateway will be in the public subnet, and this public subnet will be connected to the IGW, and it will be reaching to the internet, guys. This is how the request from private subnet to the internet is working. And then we'll come to the security groups. The security groups is particularly the firewall at the service level. If you are creating any service like EC2, then this security group will be attached to the service level. Here you can see any of the service like default subnet. No, the default security group. Here you can see the inbound rule. Inbound rule is like incoming request. So it will accept all traffic from this particular security group rule, guys. You can say that source, from this source all traffic will be allowed to this particular security group. You can mention like any of the ports, like we should not use particularly the all traffic port. You can add rule line, we can add a custom port like http, https from anyone, and you can also have to available to add your own IP address, so it's very secure. The security group was at a service level. Now we will see the NACL. This is network ACS. This is attached before the subnet. This is the firewall. It's acted before the subnet. It will filter the request from before subnet before reaching the subnet, guys. So this is NACL. And the other concept is elastic IPs. Elastic IP is like a static IP. We can able to create a allocate an elastic IP, and then we can able to attach it to the any of the resources, guys. Because whenever you are creating a, you can see here the more project elastic IP is created, because if you are going to attach this elastic IP to any of the subnet, which is like not subnet, it's like EC2 instance. If you are creating a new EC2 instance, and if you are getting rebooting the EC2 instance or starting and rebooting, then restarting the EC2 instance, the public subnet public IP will be changing. So you cannot able to directly attach this EC2 with the any of the load balancers, so that if you're accessing the EC2 with the public IP, if you are restarting the public EC2, it is public IP will be changing. For public static IP address, you will be using this elastic IP. So it will be whenever the EC2 instance get restarted or restarted, or you are stopping or starting the EC2 instance, the same public IP will be there, so that the end user will not get any errors. So this is how the VPC and the subnets, route tables, internet gateway works. This is the hands-on demo. Thanks for watching this video.